Astronomers watched a lone black hole shred a star, revealing how these wanderers reshape galaxies. This is Fascinating Frontiers, episode 157. A black hole not bound to any galaxy center tore apart a passing star in a rare disruption event. The flare produced a luminous signature across multiple wavelengths that confirmed the encounter and ruled out activity from a typical supermassive black hole at a galactic core. Follow-up observations are now planned to track how the stellar debris evolves over the coming months. Such isolated encounters offer direct evidence for intermediate mass or wandering black holes. Now, shifting focus from isolated destruction in deep space to new ways of staying in orbit close to Earth. An air-breathing electric propulsion system could let satellites operate at roughly 150 kilometers altitude, where residual atmosphere creates significant drag. The thruster scoops in stray nitrogen and oxygen atoms, ionizes them in a plasma chamber, and accelerates the ions backward to generate forward thrust. Laboratory tests show stable operation at the few hundred watts typical of small satellite power systems. At orbital velocity of 7.8 kilometers per second, the intake captures enough mass flow to offset most of the drag. The remaining open question centers on whether intake grids and electrodes can endure months of continuous molecular bombardment without pitting or eroding. Engineers are preparing an upcoming in-orbit demonstration to test these durability limits under real conditions. On a different note, measurements from the MAVEN spacecraft are clarifying how auroras form on Mars despite the absence of a global magnetic field. The mission's instruments recorded particle precipitation and magnetic field interactions that match the processes observed on Earth. These data explain the patchy glow seen in the Martian upper atmosphere. The findings come from direct comparisons between MAVEN particle and field readings and established terrestrial auroral mechanisms. Next, a newly recovered Martian meteorite is supplying fresh clues about the planet's interior. Boston College researchers dated the sample to 1.27 billion years old using isotopic analysis. The rock originated from a previously unsampled, pristine mantle source on Mars. The results, published in Geochimica et Cosmochimica Acta, add new constraints on how the planet's internal structure evolved over time. Shifting from Mars rocks to the vast web of cosmic structure, a recent study examined how dark matter might decay inside cosmic filaments. David Dunsky of New York University led the team that searched for signs of dark matter decaying into gravitons. The work, published in Physical Review D, used the observed structure of filaments to place the first observational limits on that process. Dark matter accounts for roughly 85% of the universe's mass, yet remains detectable only through its gravitational influence. Turning to events visible from Earth this summer, the Perseid meteor shower reaches peak activity under favorable northern hemisphere skies. Meteors appear to radiate from the constellation Perseus after midnight. Observers in dark locations away from city lights can expect the clearest views of the annual display. On a separate note, archaeological and ethnographic evidence shows that ancient Maltese seafarers relied on stars for navigation. Researchers identified use of the southern constellation Crux as a key reference during long-distance voyages across the south-central Mediterranean. The analysis reveals a complex cosmology that supported these maritime journeys. Finally, a striking new image captures the Rho Ophiuchi cloud complex and the Blue Horsehead Nebula looming above the Himalayas. The region lies some 460 light-years away and displays blue reflection nebulae, red emission clouds, and dark dust lanes across Ophiuchus and Scorpius. The Blue Horsehead Nebula is illuminated by a blue subgiant star. The photograph highlights how reflection and emission processes produce contrasting colors within the same area. The daily astronomy picture from NASA features 3 galaxy pairs captured in recent observations. Each pair shows gravitational interactions that distort shapes and trigger star formation. NASA released the image as part of its ongoing public outreach series. Satellite measurements of chlorophyll at the sea surface tracked shifts in ocean nutrient supplies during mid-2026. The data reveal how El Niño events redistribute plankton populations across the Pacific Basin. NASA's Earth observing instruments provided the continuous global coverage needed to map these changes. Catalyst Space reported steady advances in recovering its spacecraft designed to boost the orbit of NASA's Swift Observatory. Engineers are addressing attitude control issues that halted the original servicing plan. The company continues to test commands from the ground. Officials from Australia and Singapore held their first formal space dialogue to expand cooperation on satellite technology and space situational awareness. The meeting established working groups for future joint projects. Both nations aim to strengthen regional space capabilities through shared infrastructure. A new monument in Nassau Bay will recognize Black engineers, mathematicians, and scientists who contributed to early U.S. space efforts. The installation stands near Johnson Space Center and highlights their often overlooked roles. Local officials expect the monument to open later this year. The Soviet Luna 24 spacecraft launched from Baikonur Cosmodrome on its way to Mare Crisium. It became the final mission of the Luna program, which ran from 1959 to 1976. The probe returned lunar samples 9 days after landing. Asteroid 44 Nysa, a bright E-type body rich in enstatite, shows evidence it may consist of 3 separate components. Long-term observations have hinted at an elongated or multi-lobed shape rather than a single solid object. Further study could clarify whether it formed through collisions or reaccretion. Point a satellite at 150 kilometers altitude, and the thin upper atmosphere still exerts a steady tug that would deorbit most spacecraft within weeks. An air-breathing electric thruster counters that drag by scooping stray atoms, ionizing them, and expelling the ions at high speed to produce thrust. At orbital velocity, the intake maintains enough mass flow to keep the satellite aloft, using only the power budget of a typical small satellite. Laboratory prototypes already run stably under continuous operation, yet the real test lies in whether the intake surfaces survive repeated collisions with abrasive molecules over many months. If the grids and electrodes hold up, satellites could remain in this very low orbit for extended missions that were previously impossible. The next step is an in-orbit demonstration that will measure how well the system performs when the atmosphere itself supplies the propellant. Keep an eye on follow-up observations of that wandering black hole disruption as debris continues to evolve. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. And before you go, this show is part of the NERA Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Models and Agents, your daily briefing on AI models and agents. Find every show free at neranetwork.com. Following the long arcs, story trackers on neranetwork.com follow major programs across episodes: Tesla, SpaceX, AI, space science, and more. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly